Oh, hello and welcome to Chapter 7 IP addressing. First of all, I have to confess that Chapter 7 is probably one of the hardest chapter in a test in the program, and the reason behind that it involves a lot of numbers. So as a result, I will divide the chapter like usual into three part. Part one of the lecture theory, part two lecture, part one I will go over IPv4. Part two, I will go over IPv6, and in part three, I will do lab. And I want you to understand that this is for a lot of you. This is nothing but an introduction. So, needless to tell you, it'll be a little bit difficult, and it takes a little time before you understand it. So, I'm going to keep it very basic, and I will not go into more detail for so many reasons. By the way, chapter 8 is also another chapter that deals with IP addresses. So without further ado. So quickly, what we'll talk about this chapter, we're going to talk about explain the use of IP addresses, when and how small and large network use IP addresses. We're going to talk about this mathematical procedure, which is how to convert a binary number to a decimal number. I will talk about it briefly, and I will give you some resources and some links if you want to understand it and what do you call further, or you want to listen and learn more. Describe IP addresses, how is it broken into part, and often we consume, what is the network part of the IP addresses, what is the host part of the IP addresses. We're going to compare some a review if you want, because I know we did them before. We'll talk about some characteristics of IPv4, such as unicast, broadcast, and multicast, and when we use them in a network. Finally, in IPv4, I will explain or we'll go over what is a public IP address, what is a private IP address, and what are reserved IP addresses. We hear about this concept quite often. Finally, in IPv6, all right, what is IPv6? What IPv6 try to solve? Compare IPv6 to IPv4. Describe the representations and how we configure IPv6 and compare it to IPv4, and talk of some networking concepts from IPv6, such as similar to what we did unicast, broadcast, and multicast, and what do you call it. But we will definitely focus on the unicast. It's the most common things in a network. And finally, we're gonna do some. We'll do some troubleshooting. Use common testing, including ICMP, which is ping, and also maybe trace route or trace cert if we're talking about Windows. So without further ado, IP addressing. An IP address is, first of all, it's a number that is assigned to every single node. When I say a node, I mean any device that is connected to the network or connected to the internet. Does not have to be always a computer, because not everything that is connected to the internet are really computer. Sometimes they are just devices. A camera is not a computer, but yet it's connected to the internet. All right. IPv4, as you see over here, is usually depicted and expressed in 32 bits. And this 32-bit are divided into 4 bytes. I mean, 888, which is an 8, which gives you 32. If you look down here, all right, so if you look down here, say an example, here is an example of IP address over here in binary number. So this is not usually the number that you see. The number that you see is 192, 168, that one. That's in decimal value. But if you convert that decimal value into ones and zeros, into binary number, so you will get a 32-bit. You will get its decimal octet will have an 8 bits, and if you add all of them, you will get a 32-bit. Now, you don't do this conversion. Human don't do this conversion networking. It is a computer that does this conversion. All right, so IPv4 are commonly, like I said, expressed in dot decimal. An example, this is a computer here, this is a switch, and this is a router over here. You see that this computer has 209, 165, 200, 225. This is an example IP address, and you can see it's dot decimal. You see 209 dot, 165 dot, 200 dot. So it is divided into 4 octet. 1 octet, 2 octet, 3 octet, and 4 octet. And that's how IP addresses is. Often you see that when we do an IP addresses, just like this one over here, we'll do 192.168.10.0. You can see for octet, and when we add /24, and we're going to talk about what this /24 means. All right. So to convert a binary and IP addresses, again, you don't do this. It is your computer that does this all the time. Okay, your computer is nothing but a fast calculator. I'm sure you know that. But if you really want to see what they mean when we said an IP address is nothing but a binary number. How did we get this? How out of from 192.168 one something we get this 0 zeros and all this 1 1 1? And here is a very simple example. First of all, anytime we need to convert a binary to a decimal or vice versa, we always use this table right here. This table is a magic table. It's called 1, 2, 4, 8, 16, 32, 64, and 128. And why we call it binary? We call it binary because 2 to the power, all its numbers are a result of a number that is a power of 2. For instance, 1 to the power of 0 is 1. To the power of 1 is 2. To the power of 2 is 4. To the power of 3 is 8. To the power of 4 is 16. To the power of 5 is 32. To the power of 6 is 64. And to the power of 7 is 128. And what we mean, for instance, to the power of 2, to the power of, to the power of 1, it's 2. Time itself, 1 time it's 2. To the power of 2, it's 2 times 2. It's twice. So that's how we get this number. Again, I repeat, to the power of 0 is 1. To the power of 2, to the power of 1 is 2. And to the power of 2 is 4, and so forth. So what quickly you notice over here, that number are doubling. That's and a binary base 2. They are doubling as we go. And if you go further, you get 128, you get 256, 512, 1024, 248, and the number kept. Now, let's use this very basic number. For now, the only thing I want you to remember is just look at these numbers, 1, 2, 4, 8, 16, 32, and now they're the result of some kind of binary base something. All right. Now, let's pretend that you were given an IP address that started with 192, and you were asked to convert 192 to binary numbers. Well, how you do that? Well, you write down this table first, and you take the number 192, and you start asking yourself. And the process is very simple. It goes like this. All right, I'm going to move to the next slide so I'll show you how does it go. And we go like this, 192. How many, look, right here, how many 192 we have in 128? 1. And you have 64 left, remainder. How many 64 you have in 64? You have 1. Do you have anything left? No. So rest of them is 0, 0. So as a result, the value of 192 decimal number in binary number, it's 1, 1, and 0, 0, 0, 0. 2 ones, and the rest of them are all zeros. All right. Now let's move on to the next number, which is 168. How do we get the value of 168? It is the same thing. So 168 has 128 in it, has 132 and 8. So if you take 128 plus 32 plus 8, it'll give you 168. All right. Again, there's really a simple mathematical procedure using nothing but addition and subtractions, and you will get this value. So as a result, 168 is what? It's 1, 0, 1, 0, 1, 0, 0. And again, you can see here that 192 is expressed in 8 binary numbers, 2 1s and 6 zeros, and 168 is 10, 101, 00. Okay. Now, how do we get the number 10? Number 10 really is pretty easy. If you have a 10 decimal value and you need to convert it, again, you will always need this table. What is 10? How many 128 we have in 10? 0. How many 64 we have in 10? In 0. How many 32 we have in 10? Is 0. How many 16 we have in 10? Is 0. How many 8 we have in 10? Is 1. And the remainder is 2. Now let's take 2. How many 4 we have in 2? It's 0. How many 2 we have? How many 2 we have in 2? I'm sorry, what we did 10. We have, so we have 1. So there is an error right here. There is an error here. So 10 is 10. It should be 1, 0, 1, and it's 0 over here. There's a mistake over here. Oh, I'm sorry, because it's 11. I thought it's so. We're doing the 10. So this 10 is over here. My mistake. So I'm going to repeat it right here. This 10 is right here. This is the value 11. So I'll repeat again. How many 10 we have in 28? It's 0. How many 64 we have in 10? It's 0 because it's greater. 64 is greater than 10. How many 32 we have in 10? It's 0. How many 16 we have in 10? It's 0. How many 8 we have in 10? We have 1, and the remainder is 2. Okay, now 2. This is where you write 2 and say, okay, how many 4s I have in 2? It's 0. How many 2 I have in 2 is 1, and there's nothing left. So as a result, the value of 10, the decimal number 10 in binary is 0, 0, 0, 1, 0, 1, 0, and that's what we have in the third octet. The last number, it's 11. And we, again, we'll do the same thing. We'll take the table and we'll start asking ourselves the same question that we did before. Okay, number 11, that's what we converted now. It's 11. And the question is, how many 128 you have in 11? It's 0. How many 64 we have in 11? It's 0. How many 32 we have in 11? It's 0. How many 16 we have in 10? In 11, it's 0. How many 8 we have in 11? We have 1, and the remainder is 3. Now, how many 4 we have in 3? It's 0. How many 2s we have in 3 is 1, and the remainder is 1. How many 1 we have in 1 is 1. So as a result, now 11, and the number decimal 11 in binary number, it's 0, 0, 0, 0, 0, 1, 0, 11. So as a result, we took the IP address 192.168.10.11 and we converted it to a binary number, and it become 1, 1, and all 6 zeros, and 1, 0, 1, 0, 1, 4 zeros, and 4 zeros, then 10, 10, and 4 zeros, then 10, 11. So this is what we mean. So when you usually say a number here, 192.168, and somebody tell you, hey, this is a 32-bit, you don't really see it. Unless you convert that number to a binary number, and you will have 8 plus 8 is 16, plus 8, it's 24, plus 8 is 32. So out of this number here, you really will never know it's 32, but you really need to convert it before you can do so. All right. Next thing that you need to know about IP addresses, especially IPv4. Every single IPv4, as you can see it here, is divided in 2 parts, just like phone numbers. Phone numbers, you have the area code and you have your phone numbers, right? So IP addresses are exactly the same thing. They are 32-bit and divided into 2 parts. One part is known as a network ID, and one part is a host ID. One part is a network ID, and one part is host ID. So, and the rule for this is really simple. It said all devices in the same network have to have the same network portion. And every single device in a network has to have a unique host IP address. For instance, if you have 20 computers, and in order for them to be in the same network, they all have to, the 3 first octet for all the 20 computers have to be 192.168.10. Now the last octet has to be different. For instance, one computer had to be 10, another one had to be 11, another had to be 12, 13, 14, and so forth. I repeat before I move on. Every single device in the same network has to have the same network portion ID. That's one. Rule number 2, no 2 hosts in the same network can have the same ID, the same host ID. If you do that, you can have a conflict, and none of those devices will be able to communicate. Right? Now, how do we get this IP addresses? Well, how computer devices get this IP address? Well, we have 2 options. Option number 1, you as a network administrator, you can sign this IP addresses statically, manually, 192.168.10.10.10, subnet mask and default gateway. The other option is also possible to obtain an IP address from what? From what do you call it? From a DHCP. Obtain it from a DHCP. Every single computer, the minimum requirement for devices to communicate in a LAN are IP address and subnet mask and also DNS down here. That's true. You can communicate without DNS, but it'll be a really problem, right? So the minimum requirement for machines in local area networks to communicate with each other is an IP address, a subnet mask, and a DNS for better and faster connections. Now, if those computers need to go to the internet and communicate with other devices outside in the wide area network, hence you're going to need to end the default gateway. The default gateway is nothing but the IP address of a router. The default gateway is nothing but an IP address of a router. Next question we're going to try to answer, what is a subnet mask? What is a subnet mask? All right. You are human and you are a very powerful supercomputer. So if I'll give you an IP address and give you a subnet mask and tell you, for instance, I'll give you 192.168.1.1. Let me go back to the slide before. I'll give you this IP address over here, 192.168, and I'll ask you what part of this network, this IP here, is a host ID and what part is a network ID. The human that you are, you're going to look at this 255s over here and you can say, okay, I think 192.168.10 is a network ID because all devices, like I said before, all devices in the same network have to have the same network ID. Hence, that's why we call this one a mask. The number, as a matter of fact, if you take 255 and convert it to a binary number, it's going to be all ones. So all ones, all ones, all ones. Whenever you have all ones in subnet mask, this means that the number above or the number they represent in the IP address should be the same in all devices. All right. Now, the human that you are, by looking at this 255, in the fly, you're going to tell me, hey, I know this is the network ID and this is the host ID. If I ask you, how do you know that? So, because it's 255s tell me. Any number in the IP address that has a 255 under it there's a good chance is a part of the network ID. And any number that has a 0 there's a good part as a part of the host ID. Now, you are human and you have eyes, but computers don't have eyes and can figure out that. Now, next question is, the only way for a computer to find a subnet mask, the computer have to do some mathematical procedure, have to do math in order to figure out. Now, you may ask me, what is the job of an IP, or what is the job of a subnet mask? Well, I told you earlier, the job of one of the many jobs of the subnet mask is to divide an IP address into two parts. What part is a network option and what part is the host option? This is number one. So a subnet mask job is take an IP address and break it down into two parts. What part of it is a network ID and what part of it is the host ID? Now, beside that, you're going to see that a subnet mask is used by computer to find out if the computer they need to talk to, if it is local or is remote. Think about this. When we human need to talk to other humans, how do you know if you should talk softly or shout as I'm doing right now if you want? Well, it depends on the distance. If he's in the same room with you, or if he's far away from you. What if he's completely in different place? He's not there, right? So computers, you are human again. You have eyes and you can see the other human that you need to talk to. But computers have no idea what is that computer that they need to talk to. They don't know if it's in the same network. They don't know if it's in another network. Obviously, they don't know if it is in a completely different country. So how do computers come to a conclusion to find out if the computer they need to talk to is local or remote? By doing a process, which I'm going to talk about in part 2, known as ANDing. And what is ANDing? ANDing, all what the computer does, take his IP address, convert it to a binary number, and take his subnet mask, convert it to a binary number, and do logic ANDing. So I'm going to stop right here, and I'll pick on part 2.